Hello friends, in this video we are going to solve some MCQs on the topic atomic structure. Under the topic atomic structure, there are several subtopics, out of which in this video we are going to solve approximately 25 problems on quantum mechanics, black body radiation, spectral distribution of energy, Planck's theory, photoelectric effect, and wave particle duality of matter and light. First problem. The branch of science that deals with properties of atoms and molecules and their behavior is called as quantum mechanics. Next one, the key foundation in the quantum mechanics is its black body radiation, because entire quantum mechanics is based on the black body radiation. When radiant energy falls on any normal body, then some energy is reflected, some energy is absorbed, and the remaining energy is transmitted. If the body is normal, any body, then all these processes occur simultaneously. So answer is all the above. Next one, when the radiant energy falls on a black body, then now the body is not normal body, it is perfectly black body. Then all the energy is absorbed. Next one, black body it can absorb and also radiate energy. A black body is a perfect absorber, a perfect radiator, both or none. Both. It can absorb as well as it can radiate the energy. Next one, all bodies radiate energy. The black body radiates empty space and then energy. Maximum energy, minimum energy, zero energy, or we cannot predict. The answer is black body can radiate maximum energy. If the body is any general body, normal body, then it will radiate less amount of energy as compared to the black body. Next one, the quantitative relation between absorbed energy and emitted energy is given by it is Kirchhoff's law. Next one, the Kirchhoff's law states that at any temperature, ratio of emissive power of a body to the absorptive power is constant. The ratio of emissive power to the absorptive power is independent of the nature of surface. The ratio of emissive power to the absorptive power is equal to emissive power of black body, and all the above. Kirchhoff's law has all A, B, C in its statement. So it's all the above. Next one, the total amount of energy E radiated by a perfectly black body per unit area per unit time is directly proportional to the fourth power of its absolute temperature. This is the statement of which law? Options are Stefan's fourth power law, Wien's law, Rayleigh-Jean's law, and Planck's law. In the statement itself, you can see that the energy radiated is directly proportional to the fourth power of absolute temperature. So it is Stefan's fourth power law. Next one, in the spectral distribution of energy at different wavelengths, if temperature is increased, then the options are maxima shifts to the higher intensity and higher wavelength, the maxima shifts to higher intensity and lower wavelength, the maxima shifts to lower intensity and higher wavelength, and the last one is the maxima shifts to lower intensity and lower wavelength. The correct answer is the maxima shifts to higher intensity and lower wavelength. Next one, in spectral distribution of energy at different wavelengths and different temperatures, the area under the curve is, options are the total energy emitted by the black body per unit area per unit time. Next one, total energy absorbed by the black body. Option C, total energy distributed in the black body. And option D is the total amount of energy emitted by any body. The correct answer is option A, total energy emitted by the black body per unit area per unit time. Next question, in spectral distribution of energy, the Wien's law is applicable at only high wavelengths, only lower wavelengths, all the wavelengths, none of the above. Wien's law is applicable only at lower wavelengths. Similar question, in spectral distribution of energy, the Rayleigh-Jeans law is applicable at, options are same as for the previous question. The Rayleigh-Jeans law is applicable at only high wavelengths. Next question, energy absorbed or emitted is not continuous but in the form of packets called quanta. This is a statement of which law? Options given are Stefan's law, Wien's law, Rayleigh-Jeans law and Planck's law. The correct answer is Planck's law, because Planck put forth this concept of quantum, and the quantum is bundle of energy or packet of energy. So any body can absorb or emit energy in the form of packets, that is quantum. Next MCQ, when a beam of light with frequency equal to or greater than threshold frequency is allowed to strike the surface of metal, the electrons are emitted from the surface. This is the statement of, options given are Stefan's law, Planck's law, Wien's law and photoelectric effect. This is a statement of photoelectric effect. When light falls on the surface of metal, some electrons from the metal surface are ejected. When the energy supplied by the incident light is sufficient enough to eject those electrons. When will the energy be sufficient? It will be sufficient only when it has enough energy, that is enough frequency. That is the statement of photoelectric effect. In photoelectric effect, the work function phi is, options are threshold frequency, threshold wavelength, the energy required to eject electron and the energy required to absorb electron. In photoelectric effect, electrons are ejected and the work function phi means the energy required to eject those electrons from the surface of metal. Next one, in photoelectric effect, electrons are ejected only when options are frequency of incident light is equal to or greater than the threshold frequency. Option B, intensity of light is high. Option C, both, and option D, none of the above. The electrons are ejected when the correct option is frequency of incident light is equal to or greater than the threshold frequency. Because if the frequency is high enough, then only the energy of incident light will be high enough. And then the electrons will be removed from the outermost shell of electrons, outermost shell of the atoms. Next one, the kinetic energy of emitted electron in photoelectric effect depends upon. Options given are frequency of incident light, frequency of radiated light, intensity of incident light, and intensity of emitted light. In photoelectric effect, when the electrons are ejected from the surface of metal, they are ejected with certain kinetic energy. They have certain velocity, and therefore the kinetic energy depends on frequency of incident light. Next one, the number of electrons emitted in photoelectric effect depends upon. Options given are same: frequency of incident light, frequency of emitted light, intensity of incident light, and intensity of emitted light. In previous question, kinetic energy of emitted electrons was asked. In this question, it is the number of electrons emitted. Now, the ejection of electron requires sufficient energy to remove electron from the metal surface. But once that frequency is achieved, once the incident light has that frequency which is equal to or greater than the threshold frequency, then electrons are going to be ejected from the surface. But the number depends upon intensity of incident light. If intensity is more, then more number of electrons will be ejected. If intensity is less, then smaller number of electrons will be ejected from the metal surface. Next one, photoelectric effect explains that the light is, options are more like a wave, more like a particle, like both wave and particle, that is dual nature, and none of the above. According to photoelectric effect, electrons are ejected from the surface of metal when light strikes on the metal surface. It means that it is behaving like a particle. Next one, the de Broglie equation is, options are given. The correct answer is lambda is equal to h upon mv. This equation correlates wave nature of particle to the I mean to say the de Broglie equation correlates both the nature of matter, that is wave nature and particle nature. Here in the equation you can see lambda, that is wave nature, and m into v, that is momentum, which is of particle nature. Next one, the de Broglie considers, options are wave nature only, particle nature only, both wave and particle, that is dual nature, and none of the above. Just now we saw the equation, that is lambda is equal to h upon mv. It has the terms lambda and MV, that is the terms which explains wave nature as well as the particle nature, that is both wave and particle nature. Next one, the de Broglie hypothesis was confirmed experimentally by, options given are photoelectric effect by Einstein, alpha particle scattering experiment by Rutherford, electron diffraction experiment by Thomson, Davison and Germer, and the last option is spectral distribution of energy by Stefan. De Broglie hypothesis explains dual nature of electron or light or other small particles. So it is confirmed by the experiment carried out by Thomson, Davison and Germer, that is electron diffraction experiment. Next one, the electron diffraction experiments by Thomson, Davison and Germer explains, options are given. The correct answer is dual nature of matter, that is electron or neutron or any similar small particles, and also light. So in this video we have seen approximately 25 MCQs. Next video I will post some more MCQs on atomic structure, but on the further topics. So see you in next video. Thank you.